There we go. Welcome to the Moon's Orbit and Eclipses help session for doing the lab. See, now I'm recording. I started recording, so that I remember to record. So. All right, so let's get started. I'm going to share the screen here. Okay, and what I have here is I have this chart that we need to fill out by going to this particular website. So what we do is, I guess the easiest thing to do is just do exactly what they say in the instructions. So I just put in a search, the Moon Tonight World Time Clock. Gone. There it is. There's the Moon Tonight World Time Clock. All right, now the month I'm going to use, or actually I will start taking data for your month. Let's go ahead and use April 2020, okay? April 2020 sounds good. And I'll start there, and I just want to make sure that everybody has their data. If you already have your data, that's good. I don't know who has or who hasn't had their data. Let me put up the chat. Where did chat go? Wait, I clicked on chat. Where's my chat? My chat. Chat, where's the chat? I clicked on it. I'm gonna have to stop the sharing just so I can see. Oh, there's the chat. Here's the chat. Chat's here. Okay, so type in chat if you already have your data. So if you already have your data, have a June of 2019, already have data, okay. Okay, and what month did you guys use? Use June 2019? Okay. Okay, so June 2019 is perfectly fine. I want to use June 2020 just to start out, or April 2020. Okay, so let's use, okay, so that's fine. June 2019 or April 2020. I'll accept either one. Just make sure that when you turn in your chart, you say on the chart, or you type it in on your thing that's June 2019 or April 2020. They'll both kind of look the same. They'll both kind of look the same, but they'll be slightly different. So that when I do this chart for June 2020, or when we do our chart for June 2020, yours should look very close to the same, okay? Yours should look very close to the same, all right? Is that okay with everybody? So I'm gonna go ahead and with June 2020. And the reason why that is so I'll have everything for the summer of this year. I mean, that way I'll be able to use a different month, but show you how to do that month. And so you all can do June 2019, that's perfectly fine. All right, okay, so let's go to our, so we're going to go to the Moon Tonight clock here. Okay, so there's things that we want from this. So I want to go to June 2020. First of all, I'm not going to worry about +1 hour. I just want to go to June. So June, and I want to go to the first day. And does it give me a specific time on this thing? Once you've opened the ed page, you see animated picture of the moon, which is great.
Professor?
Yes.
Can you share your screen?
Oh, I am sorry. Thank you. Thank you. That is a very good question because you can't see what I'm doing. Okay, so here's what I'm doing. I'm on the website. And I pull all from first change the day, the time of the day to midnight. So we're going to change to midnight. So I just pull all these numbers down to 0, 0, 0, 0, 0, 0, and 0. Okay. All right. So I got June 6th, 2020. And it's 0, 0, 0. So the time is midnight. And we don't want to animate, okay? Because animate will do real time. All right, so let me get a chart ready. I'm going to do this chart in Microsoft Excel because I did not put on. You would just print. Yes.
I also believe the instructions say to change the moon to +1 day. On yours, it has 1 hour.
I was actually going to do that before I changed the day, but thank you for it. If it says it now, let's say it now. Let's do it now, okay?
Oh, okay.
Yes, you are correct. In other words, before I change the day, I do want to go 1 day. Okay? All right. All right, so now what we have is we have this. By the way, I can actually show you what your data should be for June 2019, by the way, because all I have to do is change this year to 2019. Okay, cool, huh? So I can make sure that everybody, at least the guys here, have the right data. So, all right, so there's the 2020. Okay, so June 2020. I have to get my glasses. Oh, meanwhile, I'm making my chart. I have to do the old man thing here. There we go. Because I got old man eyes, so I need to have it zoomed in here. So I'm just going to reproduce this chart that's in here on the page. So, so this is the, I'm going to put the date over here. I'm going to put the ecliptic longitude and the ecliptic latitude. And the last column, I believe, was the distance from the Earth to the moon, okay? Okay, so date, and I'm going to go ahead and fill in the dates here in my chart here. So these are the chart that are in the thing. So 1, 3, 5, 7, 11. 13. Oops. Okay, so for you guys, I want you guys to use the 2019 data, and I'll go ahead and do the 2020. Well, no, we use whatever data you want. All right, where's my home? I want these centered. I don't know why I wanted them centered, just makes it look good. I'm going to spread these out a little bit, give myself a little bit longer lines here. There we go. Okay. And just to mark my area, I'm going to zoom a little bit more. There, make it bigger. Okay, so I'm going to put this here. So once you get like the first data, the first points of data, and you know where you're looking, then the rest of the data is rather easy to take. Okay, so let me actually shorten this because it's big. All I really want is the moon. I mean, this is kind of cool. You can see what position it is. So here's the sunlight's coming from here. So you can see the position of this. And hopefully you've learned in your lecture course now about the phases of the moon. So the phase being a waxing gibbous. So the moon is on that day would be a waxing gibbous. Okay, so I wish I could pop out this table because this table is what we need. All right, so I got this on this side and this on this side. All right, let me bring up my chat, see if I got anything else. Okay. When you do the dates on a thing, I'm answering the question in the chat. Chat says, I just realized I did not change the +1 day. The data was collected from +1 hour. Does it make a difference? If you just change the date 2 days and make sure it's the 3rd and the 5th and all those, your data will be fine. If you use this button up here to change the time, and you ended up changing the time but not the date, then it would make a difference. So it just depends on which way you did it. The reason why I told where the instructions say do it +1 day, it's just easier to change the date that way. I just click the little button forward. Okay. All right. So let me grab my glasses.
Just to confirm, the answer sheet for lab 8, on it says lab 9, but is it actually?
It's lab 8. We eliminated lab 8. There was an old lab 8 that we really couldn't do without making it trivialized. So the old lab 9 is the new lab 8, and the lab 9 numbers need to be changed.
Okay.
And you might run into this next week as well. The old lab 10 is the new lab 9. Those numbers need to be changed.
Got it. Okay, thank you.
Okay, so yeah, the lab, yeah, that's why. So it's a relic. It's a relic. All right, so now let's just record data. Okay, so the ecliptic longitude. Oh, let's see how far they want us to record these things too, because sometimes they'll tell us. Okay, so it even has those little things. So the moon Earth distance, I need to round to the nearest kilometer. So that's 388,284 on an example from June 2019. For ours, it's 366,987. This number here is less than 5, so you truncate, you just keep the digits. So this one is 366,987. So I'll just put that number here, 366,987. Okay, there you go. Okay, now the next thing on our little instructions is the ecliptic longitude. This one says 40.305. So I just round that to the nearest whole degree, which is 40 degrees, okay? So over here, it's 185.6, so I would round that up. So what would that be? You can type in chat. So I'm rounding that to the nearest degree. What would that be? 186, okay? All right, so 186, so we're going to put 186 here in the ecliptic longitude. The ecliptic latitude is down here, 5.220, and we're told to keep 1 decimal point in the degree. So that would just be 5.2. Okay, so now what I'm going to do is I'm going to click this, I can click this thing forward 2 days like this to get to the 3rd. Okay, so so those of you who are, how many of you are on the website right now as we speak, taking data with me?
I'm on the website with you.
Okay, good. All right, so I want you guys to go ahead and see if you can figure out what datas to take for the 3rd. I'll give you like a minute or two for that one. Oh, if you already have the data, that's fine. A minute or two, and then we'll compare. I'll just go ahead and write the data in here, okay?
Professor, I have a question.
Okay, go ahead.
When we turn in the graph and the questions, the answer sheet one, are we supposed to turn in the one that you're doing on the Excel as well, or is
no, you don't. This chart actually doesn't need to be turned in.
Okay.
I'll know if you have the right data by looking at your graph.
Oh, okay.
The graph is the big thing here, which is so the graph should look very similar no matter which months you are using.
Oh, okay. Okay, sounds good. And then for the ecliptic longitude of nodes, and like the ascending nodes, will you be?
Oh, that I have to go over that. I have to go over that one.
Okay, yeah, that's where I was having a bit of a confusion where I didn't understand how to exactly to answer it, and I used the dates for the.
It's okay. It's okay. We'll get to how to do that. Okay.
Okay.
For whatever month it is, we'll get to how to do that. All right.
Okay. Thank you.
If we had already started it for June 2020, that would be acceptable.
That's fine.
Okay, thank you.
I'm just trying to make this at least, you know, this semester with the way that we're just doing the best we can. Okay. All right. So here we go. Ready? Let's see. So I got 215. Hopefully you got 215 for that one. This one is 4.3. And this one is 364,381. All right, let's go. So I'm just going to start taking the rest of this data here. Okay, so 244. once you get used to where to looking, 2.2 and 366,624. Okay, 7th is is that construction? Okay, can the person with the construction mute yourself unless you have a question? All right, here, hang on. I got to go do this. Hang on. Is somebody like snoring really bad?
It seems to be coming from some guy named Bryant Martinez.
All right, here, hang on. Ready? Okay, that was him. All right. Actually, he was the first one I was going to mute anyway, so that's so it would have worked out anyway. I was actually going to go through, mute each person to see when it stopped, mute and unmute, you know? So, yeah. All right, so here we go. Let's see. We are in the 9th. We're on the 9th, and so either that or Bryant went to sleep on us. 299. So 299 there. Move you guys out of the way. And this is negative 2.7. And this is 384, 317. Okay, 11th. 394, 651. This one, negative 4.4. And this one is 325. 13th. The 13th here is 401, 975. Whoops. Sorry, that goes here. This one, 349. Oh, 350. And this one is negative 5.2. 15th. It does get kind of boring after a while because you're doing the same thing over and over and over again. But we'll get there. Let me move this over, actually. Move this over. All right, so ecliptic longitude here, 13.13. Notice how the numbers went back through onto the other side now, so we got 13. We have, this is negative 5.1. And this one is 404,594. Seventeenth, here it comes. This one is 402,382. This one is negative 4.2. And this one is 37. '19th. 88. Negative 2.5. And 396,553. 21. Almost there, people. 21st is 90. Whoops. I'm sorry, not 90. 87. There we go. Wait a minute. That's wrong. I'm reading the wrong things here. Wait. No. That's not right. Hang on. I got to go back up. Uh-oh. Somebody didn't stop me. Let me go back to the 19th. Ah, this is 61. Sorry. Got to be careful. See, even old men need to be careful. All right, this is 62. There we go. So correct that. The negative 2.5 is correct, and the 396 is correct. 396.55. I read the long line. I read the wrong line there for the. I'm sharing my screen.
Yes.
Okay. Okay, I'm sorry. Somebody asked in chat if I could share my screen. So if like you click on me, I'm not sure what the individual lets you do, what your individual views let you do. I don't know if you can click on a specific person or not, but there should be some place where you can click at least on my screen share. Okay, so I'm back. I need to go back to the 21st. Okay, so 21st. Okay, for the 21st is, now we're at 87. There we go. Now we're at 87. We're at negative 3.3. No, negative 0.2. Jeez. There we go. Very good. Yeah, and 389.042. All right, so we want the 23rd. By the way, if I mistake any of this data, please let me know, because you know, the older I get, and I'm probably just going too fast because I'm thinking, oh, I gotta hurry, and you know, me being in a hurry. Bad professor, bad. Should not be in a hurry. Plenty of time. Okay. All right, so our ecliptic longitude here is 113. The ecliptic latitude down here is 2.1. No, yeah, 2.1. Oops, 2.1. And this distance, 381,740. And our last piece of data. Wait. Oh, sorry, everybody. All right. There we go. 25th first. There we go. We got the 25th. All right. So here we have 140. Down here we have 4.1. And over here we have 375,826. And for our last piece of data, we have 168. .2 and 371,664.
Professor, I think the data for the distance from Earth to Moon for the 21st, I think it's
Okay, let me go back and check it.
yeah.
Okay, 21st. All right, let's do it this way. 389,043. Okay, I see. I didn't round that properly. Like that?
Yeah.
Okay. Thank you. All right.
No worries.
Okay, so let me do this. I'm actually going to save this file because this is a cool file. So save as. This PC on my desktop, which is messy. I know it's, so this is June 2020 moon data. There we go. There we go. All right, so here's our moon data for June 2020. All right, so now that we have this data, now we're going to try to make a plot. And this is where things get a little start getting confusing, because it's the one kind of mathematical thing that we do expect you to do, is to be able to graph these things. But some of the graphs are more confusing than others. So we're going to be graphing this ecliptic latitude versus ecliptic longitude on our graph. So let's pull out our graph here. Oh, I believe I put that somewhere. I got an idea. I'm going to put my paint file here. See if it gives me any recent ones. Lab 501, device, big polar chart, big polar chart. Wait, is this the big polar chart? Big pole chart. Let's see if this is it. No, that's the polar chart. Darn. Okay. Where did I put that? Oh, I'll just download it from online. That's why I gave it to you online, okay? So people have been talking to me about not having a printer and not being able to print out stuff. So what I've done for you online is, if you don't have a printer and cannot print out the chart, I don't recommend doing this unless you absolutely have to, because it's really hard, especially if you're trying to use something like Microsoft Word to do it. I would rather use a, what do you call it? The Paint program, or some kind of photo, maybe even Photoshop or PowerPoint or something where you can actually save it, and then save it as a picture. Because what will happen is, even if you make the dots correct on the chart that you're editing, then when you go to save it on like a PowerPoint or a Microsoft Word, it moves around all the dots, which is why I would rather you directly do it. But because of the whole printer issue, you know, we need to allow for people not having to have a printer. So I'm going to download this, which is a JPEG file. This is a simple JPEG file, and you can kind of scriggle in your signature over here, okay? And for the date here, instead of putting today's date, why don't you go ahead and put the date that you're taking the data. Say this is for June 2019 or June 2020. That way I'll know what to look for. All the charts should look similar, okay? Oh, no, I don't want to open it here, okay? Well, I put it in my downloads, okay? So I'm going to go to my downloads. Downloads, please. Thank you. Give me my Eclipse chart. Move to desktop. Okay, now just give me my Eclipse chart. Okay, so I'm going to this. Where'd my Eclipse chart? Oh no. Where'd it go? I did put that in my desktop, right? Oh, great, I don't see it. This is what I get for having a junky thing. All right, let's see if I can just do this. No, not that. This. All right. See if I can, maybe I can just find it on here. There it is. Okay, so I'm just going to open this. I'm just going to use the paint file. Okay, I'm just going to use the paint to do it. All right. Here's the paint. Now I don't know how well you can label this or whatever, but here's what I'm going to do for this particular thing. Let's see. Let's go back. Let's go back to here. So what I want to do is I want to have a point here. I want to have dots somehow. So I guess I'll just use little tiny circles to do it. Or I guess I could do little tiny, you know, I'll just do little tiny circles somehow. I'll just do, I want a tiny circle, and let's make them, I'll make them colored since I'm here. So I'll just make it colored green. And let's see if I can do a little circle over there. So I'm going to do a little circle here. Okay, is that? Okay, that's okay. Give me the circle. Oh no, undo that. All right, so give me a circle again. Let me try to do the circle again. Color two, color two. Let's put you also green. See if I can do the circle right. Okay. And if I do this, can I copy? Can I copy this? No, I can't copy it. Okay, well, there's a circle, so, but I can't move it from here. Okay, I got an idea. Let me try this. Let me try this now. Because paint's gonna be a little harder for me to use because I can't just directly move this like I'd like to. I would like to just click on this and copy it, but it doesn't save it. So you would have to put it in the point already. All right, so here's what I'm gonna do. Get out of here. No, I'm not gonna save it. All right, I don't like Word, so I'm using PowerPoint. Give me PowerPoint. No, I would like a new one, please. Thank you. I would like this. Thank you. I'd like to get rid of these. Thank you. And thank you. All right, now we're somewhere. All right, so if you don't have PowerPoint, just need some kind of draw program. I just wanted one that was a little easier. So what I would have to do with that one, that particular one, is if I didn't have the point correct, I'd have to kind of move it. So instead here, I'm gonna just look for my ecliptic. I know it's on the desktop somewhere because I just.
Professor, I have a quick question.
Go ahead. Go ahead.
Are we still able to turn it in with printing it out and turning it in that way, or does it have to be?
Oh no, no, no! I prefer if you printed it out and did it that way. I prefer that. Please, if you could print it out and do it that way, do it. You see how much trouble I'm having with this? I'm just doing this because some people do not have printers. Some people don't have printers. And if you don't have a printer, you have to do it. You have to find some way to edit it, you know, directly. All right, so where's my thing? Where'd it go? Here, let me just. Let's see, insert. I want a picture. Give my desktop. Give me that. All right, there it is. Okay, so now we're going to use this. Okay. I don't need this anymore. I don't need this anymore. Okay, so there it is. I'm going to go full screen here. Oh, actually, I can't. I need my data. Where's my data? Here's my data. Okay, so I'll put my data over here. Okay, hang on. All right, so you guys are going to have to help me, I guess. Somebody's going to have to tell me. Well, actually, I'll just look at the data here. So I want something at 186 ecliptic longitude and 5.2 ecliptic latitude, okay? So if your numbers for June 19 are going to be different, yes, they will be different. So you should get a similar looking graph. It won't be the same though. It'll be kind of shifted. It'll be kind of shifted, okay? So in fact, I think the June 2019, guys, you're actually going to start your plotting down here somewhere. Do you see where I'm circling my, can you guys see my mouse? Okay, so June 2019, you should have started here. Is that correct? You should start somewhere down here.
Yeah, it's in the bottom left.
It's in the bottom. Whereas for the June 2020 people, we're going to start kind of up here. Okay. All right. So we have 186 and 5.2. I'm going to go to insert, and now I'm going to insert a shape. I'm going to insert a little dot here. And in here, the cool thing is that I can put the dot here. So that's my dot. And now if I want to just do it, I can just copy this, and so I can use the same dot for every point, okay? So I'll just copy this thing. Give me this, I want to copy. Copy. All right, so now I'm going to paste. Okay, give me this. So now what I'm going to do is I'm going to drag this thing over to where it should be. So give me you. No, I made it bigger. Okay, fine. I'll just drag you. So 186. So this is 180. So let's figure out how long each of these lines are here, okay? So I want you to type in chat. So if I look at this, this is 0 to 60, and see how many lines I have. 1, 2, 3, 4, 5, 6. So there's 6 of those lines from 0 to 60. So how long is each of those lines? Okay, so each one is 10. All right, so I want to do 186. I want to do 186. So that needs to be between 180 and 190, and maybe slightly closer to 190. So the best I can do here is to make this kind of here, like kind of closer there. So notice it's kind of closer. My little ball is really too big. I'll make it a little smaller. Okay. All right, now I need to move it up to 5.2 because I have positive 5.2. Now the thing is, let's figure this out. So there's 3 of these marks in every degree. So each one is a third of a degree. So what is a third in decimal? There we go. Andrew already answered that question. 0.33. So this point being 5.2 will be below, somewhere below the 5.3. So that puts it about right there. Okay, that puts it about right there. And there's our point. There's our first point. Isn't that great? We got the first point. Yay! All right. Okay, so now I'm going to copy this. Now we'll paste this over here. Okay, I pasted here. Now let's see if I can get it to move. Come on. Can I move it? Good, I can move it. All right, so the next point where we need to move to is 215 and 4.3. So somebody turn on somebody who's using this data, I need you to tell me where to stop. Moving to the right. I'm moving to the right. Moving to the right. Moving to the right. I'm still moving. Oh, yeah, I went too far. So this is 180 right here. So 190, 200, 210. So this blank line is 210. So it needs to go about right there. And then the other one, the ecliptic longitude is 4.3. So that's just beneath this line right here, kind of there. All right. All right, let's do another one. Gotta move you further down here. All right, so now we have 244. Okay, so that's just after 240. And the 2.2. So there we're going to go. Notice how quickly we're dropping now. So quickly drop down to here. Okay, so we're at that. I think that's close to being right. Okay, let's just go ahead and do another one. Going to be down here somewhere. Let's see, 272. So this line is 240. This one is what line? What line is this one right here?
The 270.
This is 270. So we're just past this. And we want this to be negative 0.3. So we're in the negative just above this. Right there. Okay, I'm now going to copy this one. Just so that when I go pasting, it'll be a little closer to where I need it to be. It'll be way up there. Okay, so now, okay. We're at 299. 299 is just less than 300. So is everybody understanding how to do this and how much fun this is going to be? And let's see, the thing now is negative 2.7. So here's negative 2. So this is negative 2.66. So we're beyond here to negative 2.7. And I'm going to go back to my data here. Put my data over here for a moment. I'm burying my data. There we go. All right, so now we go to 325. Hopefully you guys are doing this on pencil and paper. Much easier on pencil and paper, right? What line is this right here? This is a little tricky. So that line right there is what?
3:30.
2:30.
This is 330. So 325 is going to be halfway between 320 and 330. That's the best I can do it. And I need negative 4.4. So this is negative 4. This one is negative 4.3. And so negative 4.4 would be about there. Okay. Paste again. There we go. Pull this over here. Next, we're at 350, which is right on this line. And it is negative 5.2, which is down here. About right there. Okay, that's my guesstimate there. All right, now notice what happens. Notice what happens, the thing loops back over to the other side. Okay, because remember this is a circle, and so this is like the sphere. So this actually wraps back around over here. So in other words, when the moon is moving on this, it actually moves from here over to here. You don't draw the line. Don't draw a line from here back over here, because it actually you draw the line going off the page this way, and it would come back over here. So let's go ahead. We're going to jump to the other side. So let me go back and actually let me do one more pasting here. One more pasting here. Thank you. And now we're going to move this all the way back over here where it's supposed to be. All right. So the degree here is 13, and the number is negative 5.1. So 13 is about right here because that's 10, and negative 5.1 is down here. Okay. So notice that even though our numbers are different, and we definitely started in a different place, notice the graph is actually going to kind of look the same as the one from 2019. If you guys have done the 2019 already, you know, it starts, the 2019 folks, you basically start down here, go up, and then go back down. Well, we started up here, go down, and then we go back over here and do this left half. So cool, huh? Cool stuff about the moon. All right, let me go ahead and copy it here. So now I can paste for the last view. So I'm gonna paste. Uh-oh, what happened? Okay. Click on this. I'll copy this. No, stop it. Copy. Okay. I better save this. See what I mean about using these print programs, things and stuff? That's why I would much rather you guys do this on your own, you know, your stuff, okay? Moon graph, ha ha. There you go. Save it. Right there. All right, so now we got to move this point to where it needs to go. This point needs to go to 37 and negative 4.2. So if I move this over, here's 30. 37 is about there, and negative 4.2. So you got to be here. By the way, be careful, because when you're plotting these things, you might think, oh, I want to plot negative 4.2, but that doesn't work because you're on a negative side. So you want negative 4.2. You go away from the center to put it there. Now it's 62. And negative 2.5. Okay. And then it is 87. That's almost 90. Over here. And negative 0.2. So up here. Then we have 113. So here's 110. So 113 would be right here. And then we have plus 2.1. Okay, 2.1. $140. That's on this line right here. And we go up here, 4.1. About right there. And then finally, 168. About right there. And 5.2. And back up here. Okay. So your points should look like that. Okay. And for 2019, if you drew your graph should look very similar to this. Hopefully it does. Let me save this puppy. Oh, no problem, no problem. I had like a couple of files that I could put in the discussion boards that showed an example of this and how to do it. But those have been lost over the years because for some reason they have emptied out my old courses that are on Canvas. I don't know why, but go ahead. Go ahead, Andrew. You have a question. You can unmute yourself if you would rather state your question. Oh, we're not done yet. I'm not done yet helping you this one. Andrew, question? Yes. So in other words, the last 2 points, you're going to end up coming back over here, I believe, for June 2019. So it loops around. So we looped around in the middle in 2020. It loops around in the middle for June 2020. But for June 2019, you start kind of down here. It goes kind of the similar pattern, similar, not quite the same, but similar. And then over here for the, oh no, I gotta show you how to do the analysis here. I want to show you how to do the analysis part, or at least how to get those. I got to show you how to get those nodes. Okay, so you're gonna mark the dots, and then you're gonna connect them. And you want to connect them with what we call a smooth curve. In other words, you don't just line. If I just went line to line, dot to dot, I guess you could kind of get away with it here. But what we'd rather do, because this thing is kind of a curve. If you've ever seen like a sine function or a cosine function, it kind of looks like that, kind of like a wave type of thing. So I'm going to see if I can do a.
Should we label them?
Yeah, you want to try to label. It's a little bit difficult on here, but I want you to label them with, actually, you don't have to label them with June, just label them with the date it is. So 1, 3, 5, 7, label them that way.
Okay.
Okay, 1, 3, 5, 7. That way I'll know which date's which. All right, so let's see. Let me go over here. I'd like to insert, let's see, what's this? Is this it? Curve. Okay, well, let's see if I can do that curve. What's it say to do? What's this? Scribble. All right, I'm going to try this. Let's see. I need to change my color.
Professor, you said label them with the days, right?
Yeah, the 1, 3, 5, 7, that. Because I'll know what those, I'll know that you're going to write your month somewhere, either up here or over here somewhere. So if you have the date on here, you write the date, your month and date.
Okay, thank you.
Mm-hmm. Oh, the one you're doing with me in chat? If you're doing it with me on your computer, sure. I do want the one you did, not the one I did. So, okay. All right, I'm going to try to do scribble here. if that doesn't work, I'll just use straight lines, even though the lines aren't going to be good. I want you guys to connect it with this. So I'm going to draw this, and I need a different color. I want a different color. Let's see. Picture border, picture effects. I want it to be a nice little scribble here. So I want here format. Now this is no outline. If I go here, where's my color here? Shape fill. Let me make this red. All right, so let's see if no, I don't want red. Let me make it orange. Orange sounds good. Okay, here we go. So I'm going to try to draw an orange line here. So I start here. It's not orange. Oh well, I'm doing this the best I can. All right, so go up here, go through here, up here. It's a mess. All right, this is the best I can do here. Don't laugh too hard. Definitely, if you're pencil paper, you're better than this, but there he goes. All right. Oh, well, I missed. It's okay. All right, I need to change this. I want to change the color here. Oh, I got shape outline. I want to change outline. Different. Orange. All right, there we go. Orange. All right, so there's my great graph. It's not that good, but yeah, just add a text box with the dates next to the point. Yeah. All right, so what I wanted to show you is how to do that ascending and descending nodes thing. Okay, so once you draw your graph, I'm going to pick the descending node for this one. The descending node is the point where this scribble crosses that line. I know it's a bit nervous, so this is going to be a little off. So what you do is I'm going to draw a straight line here, and I want that line to be a different color. I'll make it purple, and we'll draw a straight line here like this. And I guess I'll need to make it a little thicker than this. Yeah, I'll make it thicker. No, it's the color line. Where's the fill? What's the outline? And I thought it was purple. Why isn't it purple? There it is. All right, so, and I'm going to make it dotted because it's not actually a point here. I'm going to make it dotted here. Now, this is me. This is me. I'm just trying to do this to show you how to do it. So what you do is you take the point where this crosses the line here. Okay, and I want to read the ecliptic longitude of where that happens. Okay, I messed that up. Okay, I've got an idea how to do this. I need to make it a little shorter. I'm sorry. There. Okay. So I'm just doing this to show you how to do it. This is actually a bit incorrect, to let you know. The reason why it's a bit incorrect is because I scribbled and my scribble doesn't really follow, but this will give you the idea of how to do it, okay? So I'm gonna actually do it for this one here, and I'm gonna leave the other one for you guys to do. All right, so this one here, I read that off the chart. So in other words, I look for this position right here. So I'm actually going to insert a shape. And I'll insert a triangle. Give me my triangle. I'm gonna put a triangle here, and I'm gonna make it a different color triangle. I want it to be a maroon triangle, okay? No, not maroon. I want it to be a, let's see more fill colors here, just so you can get a yellow triangle. Yellow. No, that's not yellow, that's ugly stuff. All right, give me this, that's better. Okay, there we go, yellow triangle. Okay, the yellow triangle, and that's going to be my node, okay? So I'm going to put the node, this at my node, okay? So I'm going to copy this, I'll paste it. Now I'm going to put the yellow triangle at my node, and my node is where this line crosses that. See that? That is the node. That is a node. It's where that line you drew crosses the ecliptic. Now, those of you who did 2019, one of those points was actually kind of done for you, because one of the points actually kind of landed so close to the line itself that that point is pretty much where the node is. This one, you have to use the line. So you use the line, and I go down here, and I read this number off. So I want to read that number. What is the ecliptic longitude at that node? And by the way, which node is that, ascending or descending? You can type in chat.
Descending.
That is the descending node, okay? Because it's going from low to high here and high to low here, okay? So that's the descending node. And what is the number that you would read off of there? What is that number for ecliptic longitude? If you're plus or minus 1 degree or 1 or 2 degrees, I'll be fine with it. Okay, 268, that's good. I would have also thought maybe 267 could have also been, because you know it's closer to 270 than 260. So you know it's got to be in that upper half. It's kind of almost there. So you're really estimating at that point. Okay, so that's 268. 268. All right, so there's one more thing that we need to do that I want to do here, and that is a complete example. I'm just going to make up one of these ecliptic longitudes for the node, and I'm going to show you how to do that whole date thing. What day does it represent? So you go back to, you can just do a new slide, right? Give me a new slide. Thank you. All right, so insert text box here. I'm basically just typing text here. And I want it to be big, 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 so you can see a giant text. I don't know. I don't like blue. It's funny. I used to like red when I was a kid. As I got older, I kind of like blue. And then finally, I just ended up with brown as a favorite color because brown's cool and ordinary. All right, so I'm going to roll my dice here that I've got. So this is a complete made up example. Okay. So let's say the node was found at 165 degrees there it is, ecliptic longitude. Okay, so then what we do is the first thing is I divide by 30 and get a remainder. Actually, let me change that to 163. I don't like 163. 163. Okay. So I first divide by 30 and get a remainder. So this isn't this isn't what you would do with your calculator here because we want a remainder. So it's old school where you took it and divided. Okay, so when you divide this 163, so what is the number you get and what's the remainder?
Five and 13 is the remainder?
Yes, very good. So when you do this, you get 5, 30 goes into 163, 3. I don't want to put numbers together here, so I'll just put dot, dot, dot. 5 times with remainder 13. Oops. Fine. I'll just. There we go. Perfect. Okay. So now that's what we're going to use. So the first thing so to do our estimate here, we're going to say, first of all, we start with March 21st. Start with March 21st. Move the whole number of months forward. Okay, move the number of months forward. So we're going to move 5 months. So we got March, April. So 1 is April, 2 is May, 3 is June, 4 is July. Oh, I'm sorry. Shawnee and Jessica, you're confused at how we got this 5 with remainder of 13?
I get how we got 5 remainder 13. Like, I know we do the long division, but I'm a little confused on like what we're doing.
Oh, okay. Right now we're trying to find the date that corresponds to 163 degrees ecliptic longitude. So in other words, once we find our node, there's a specific date that corresponds to. We want to know the date when the sun is going to get to 163 degrees ecliptic longitude. So there's a date that corresponds to that node. And that's what we're trying to find.
And so by doing that, you do the 163 divided by 30.
Yes.
And so what do you do with the remainder 13?
Hold on.
Oh, okay.
We'll get there. Okay. So the first thing you do is you take the whole number. You're going to start with March 21st, and you're going to move 5 months forward. So we move 1, 2, 3, 4, 5. August. Okay, that's 5 months forward. So now blah, 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 excuse me. That brings us to August 21st. Okay.
So why would we start with March?
Because March 21st, the spring equinox, is when the sun is at 0 degrees ecliptic longitude.
Okay.
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 So that's when we start our astronomical, thing where we've chosen the vernal equinox to be our 0 point in the celestial sphere. So that's fine. So that's kind of the special point that we've chosen. So that's why we start on March 21st. Okay, so that brings us to August 21st. And so now what we do, then add the remainder number of days to it. So in our case, we're going to start with the 21st and we're going to add 13 days. Now I'm going to actually count this out just because the months are different. So here's a little different. So 21st, so 1 is 22nd, 23rd, 24th, 25th, 26th, 27th, 28th, 29th, 30th, 31. Okay, so let's see how many days we used up here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 10 of them. Now I have to move 3 more, and I'm going to go into September. So September 1st, 2nd, 3rd. And yeah, you would do the calculations for both. So this is the place on the answer sheet where it asks for the days corresponding to the nodes. That's what we want here. The days corresponding to the nodes. So my date here would be September 3rd. And that's the date I would put down.
And this is just an example, right? This isn't
That's
like
totally made up example. I randomly rolled dice to get the number I was going to use. So. Okay. No, you can't use a 168 because a 168 is not the number. I'm just showing you the method here. So the graph and stuff you can put in, use. You need to label it and everything, but you need to edit and do it on your own. Okay, so in other words, you can't just copy my graph, but you can do your own graph. It looks like mine's fine. In fact, the other graph from June 2019 looks almost like mine. right? So you guys did the June 2019. It almost looks like mine. No, you don't roll dice as lit. Okay, up here, this is where I showed you how to find the node. The node is where this line you draw connecting the dots crosses the ecliptic. That's the node.
Do we just kind of guess where they are? Because it's kind of hard to tell where exactly they land.
Yeah, you estimate. So in other words, when I come down here to, so in other words, I kind of draw, so I draw the curve without worrying about where it's crossing the line. I just draw the curve connecting the dots, okay? That's all I was doing. And then I look where that crosses the line, and I come down here, and as long as it's, yes, number 2 on the answer sheet, yes, okay? And as long as it's reasonable where it is, it's fine, okay? So in other words, it crossed here, and then you read it off of here. So what you want to do is you want to kind of use a ruler or something, or draw a line like I did, to bring this down so you can read it off of this chart.
Right. So for 2019 and 2020, the ascending and descending is kind of opposite.
No, no, this is the descending node right here. So
Okay.
the ascending node is over here for both of them, and the descending node is over here for both of them.
Wait, so
Okay.
where's the ascending?
Oh, the ascending node, on this one, it's over here. It's about right here on the thing I drew.
Okay.
Okay, there's a shift in about 19 or so degrees. There's a shift of about 19 degrees between each year, which is why we end up getting eclipses at different times and stuff every year. So when I first made this, in one of these, like in 2007, the graph looked like this. People started up here and went down here and then came back up like this. So the ascending node is when so you're drawing your line from left to right. The ascending node is when it goes from negative to positive, that's ascending. In other words, it's going up. And the descending node is when it's going from positive to negative. That's the descending node. All right, I'm going to leave you guys to finish this up. Thank you for coming. If you have any other questions before we go, that'll be fine. I'm actually going to stop the video here. Okay.
Thank you so much.
You're welcome.
Can you pull back up the slide that showed us how to find the